Hey everybody, it's Chili here, and I'm going to do something a little different today. I'm actually working on, shut up, you go away. I'm working on adding some support for some compressed sound formats, loading, compressed sounds in the framework so people can add music to their games and it won't make the file size like 100 megabytes. So, I'm doing that and I figured, you know what? I am going to record myself just working through this. So this ain't going to be a tutorial. I'm not going to be explaining shit that much. I might, narrate some shit as I go along. Mostly I'm just giving you guys a peek into what I do when I'm trying to develop some new stuff using maybe some technologies that I haven't used before. That sort of thing. Because a lot of people, they're like, okay, yeah, I know how to program, but whenever I want to do something, whenever I want to learn about, like Direct 3D or OpenGL or, some audio thing or Windows API, I can't do it. I don't know where to start. And I'm just like, you just gotta fucking Google that shit, man. You just you find the resources and you just start fucking around until you figure out how it works. And they're like, I don't know, man. I can't do it. I need the steps. Give me everything. And I'm like, nah, it's not how it works. So maybe if I show you guys what I do, you get an idea of what's necessary to, develop your own shit in a platform, I don't know, whatever. Let me do my thing. I'm going to program. So just a little background on this thing. At first I figured I was going to do it with OGG because, OGG is open. It's unencumbered by patents. It's good stuff. I've seen other games use it. But I downloaded the OGG and the Vorbis and I built it. I got the library files and I tried to import them and I built some shit and fucking missing symbols and looking around and shit and it's weird bullshit that shouldn't be set in I don't want to go over it. I could go over it, but I don't want to go over it. I don't want to touch it anymore. Fuck you, Vorbis. You can fuck right off the edge of my dick. That's what I want to say. So, Vorbis is out. I figure, you know what? This is Windows. I mean, my fucking audio library that I built here is X Audio. It's not platform independent. There's no real need for me to make the decoding part platform independent. So I figure, you know what? Windows has got built-in MP3 decoding in there somewhere. Let me just use the shit that's in Windows. There's a couple options for that. I could go for what this guy is talking about here, which is Direct Show. I think it's Direct Show. And I guess it would probably work, but I don't know. Direct Show seems kind of old and it could be fine, but I found something else. So I just, looking through the results for this query here, Windows decode MP3 C++, pretty simple search query. And I found a tutorial here, decoding audio Windows. And it uses, let's just click it. It uses something called MF Media Foundation or something. I don't actually know what it is. Where is it? Media Foundation, that's what it is. So it's using Media Foundation, which is something that I guess came in around Windows 7 era. So it's a little newer. It's not deprecated or anything, I don't think. So I think this will be a nice starting point for me. It's got a tutorial here. It's got a lot of example source code, which is what I look for when I'm trying to learn something new. Documentation of the functions and everything is great and it's important, but I want a thing that I can, try to get working in my IDE. I can build it, and then I can take it apart, and then I can reassemble it the way I want in my final product. So it's nice to have some example code like this. This is what I'm going to be using. And this thing, its job is loading a media file, audio file, compressed audio, and then saving it as a wave, uncompressed pulse code modulation wave file. But what I'm going to be doing, my end game, is not to save as a wave, but simply to take the PCM samples and jam them into the sample buffers for my X Audio thing here. So in sound here, you've got, where is it? Here you go, you got the P data. This is where the samples are. I'm going to want to put the stuff that I load using this shit into here. And like I said, again, this isn't a tutorial, so don't expect, there's not going to be a lot of editing. I'm not going to be talking the whole time. I'm going to be working. But I figure some of you guys might be interested, so I'll put this up here as maybe a little bit of an experiment, and we'll see if you guys like it. Maybe I'll do more of these from time to time. It's obviously a lot easier for me to code when I'm not on the camera for various reasons, but if you guys get something out of this content, then I guess it's worth it for me to turn the camera on. Let's get started. So, what do we got here? I think I've dug into this a little bit already at work, time thieving. So, what I wanted to do, implement WinMain. What do we got here? So we have to initialize COM, the COM library, component object module. I think that's what it's called. Now, I don't know if this is actually necessary because COM goes through, like, a lot of things are built off of COM, right? And I think Direct3D is also COM, so I'm not sure if we need to initialize this. And I'm actually not sure if it's already initialized, if we try to initialize it, what happens? Or if we try to deinitialize it. So, what I'm going to do is, if I just search for this, co-initialize EX. And so this is reserved. So this one, it's got, you can pass in some flags that tells it how you want to initialize it. All right, so here's what I'm looking for. COM library was initialized successfully. If it was already initialized, this will return false. And if this call tries to initialize it with different parameters than the last call, then it's going to return this value here, whatever this is. RPCE changed mode. Remote procedure call changed mode? That doesn't make any sense. Specified the concurrency mode says multi-threaded apartment. This could also indicate that it changed from a neutral threaded to single-threaded apartment. I don't know. I don't really get it. But anyways, it's going to return false if it was already initialized. Now, the other thing is, when you initialize, usually these, when you're initializing these library things or frameworks or whatever you want to call it, I don't know. When you initialize them, you've also got to call uninitialize at the end. So these have got to be matched. Now, what I want to know is if I uninitialize twice, does that give me problems? Thread must call co-initialize once for each successful call it has made to initialize. So we've got to check to see if this was successful, and then if it was successful, we've got to uninitialize at the end. All right, so let's copy that, and let's go into here. Yeah, so what I want to do, if I go back to the front, no, there we go, constant auto HR co-init. There we go. So we remember whether or not the initialization was necessary. Stop it. All right, and then at the end we go if HR co-init is equal to s underscore OK. This will probably work for most things. Then we want to go uninitialize, right? So here we're initializing COM, uninitializing COM. Let's run that. Yeah. Let's do this here. Go. Okay, so we step over this. Let's see what we get. SOK. All right, so that means that creating graphics, which does a whole bunch of Direct3D stuff, that does not actually initialize COM for this thread for whatever reason. I don't really get that, but doesn't matter. So, and then we uninitialize, and that should work fine. Okay, so that's great. And you might notice I'm just doing this shit here in game. I usually, when I'm fucking around with an API, I fuck around with it in main or in equivalent of that here. I do it in game, the constructor of game, just to get things straight. I just do everything in one function, and then later on I refactor it into a better object-oriented model that organizes things and makes it a lot more extendable, a lot more maintainable. But for now, just put everything in one fucking function. It's all good. So we got to initialize COM, then we got to initialize the Media Foundation platform. So I'm not going to check. I'm not even going to check COM here. I might do that later on when I do it for real. But right now I'm just going to assume that the COM is initialized no matter what. I'm going to go const auto hr mf, doesn't matter. Okay, now mf startup, it doesn't know what this bullshit is because I haven't included the headers. So let's just look through here. Let's include, Windows is going to be included with ChiliWin. So let's include all this stuff. Probably won't need it all. We won't need standard IO for sure. Maybe I'll just get rid of that. I don't know. We'll leave it. It would actually be nice. Now that I think about it, I almost wish that I would have started this just in a whatchamacallit, like just in an empty project with main, because then I could at least get some console output. But yeah, we'll see. Maybe I'll copy the code, paste it into a just a console project later on if I find that I really want it. Now that has gotten rid of this problem here, MF startup. And we want to do the same thing. We want to just, I imagine we want to call MF shutdown or something. Where is it? MF shutdown. Colon initialize. This one isn't even checking, it's just calling them. I'm going to call it, again, if the result was S over SOK. So actually, I'm going to copy this. Paste that there. Then we're going to copy that, paste that there. Copy this. Paste this here. Okay, so here we're going to initialize COM. We're initializing the media foundation. Yeah, build it. Let's see if we get some. Yeah, okay. We got some unresolved external symbols because we don't have we're not linking to the libraries for the media foundation. But this tutorial has given us a list of libraries right here, a link to the following libraries. And I'm just going to do it, you know, the way I like to do it, which is pragma comment library, no, library, and the name of library. If I can get my mouse and everything all good. So we'll put this one in here, copy that, paste, and you go in here, and you go in here. So that should be all the dependencies that we need all set up here. And this should now build and run fairly well. Let's see if we can initialize this stuff. So returns SOK. Next one returns SOK, and then we can shut down, and we can shut down, and no exceptions were thrown. All's good. So where do we go from here? Well, I mean, looking over this code, you see here, it's going to load, it's going to create a file. What is it doing here? What is it doing? So after it starts up the media foundation, it does MF create source reader from URL. And here is a string, wide string for the source file, and a null, and this is the address of a pointer. So it's going to be filling this pointer with, so that it points to a new P reader, and it's going to be a com bullshit thing. So that means we're going to have to be calling release on it when we're done. See, P reader is probably going to be a released call down here somewhere. Where is it? Safe release. Yeah, okay, P reader. There you go. So what do we want to do? Well, I guess first off, we want to try to call this function on a file that's hopefully in our folder. I think I put one in there already, but I will check. So we just copy this. And again, auto. Now, we don't have the source file, we don't have the P reader. So now normally what I like to do with COM bullshit is I like to use the smart COM pointers, but I'm not going to use that for this. I will use it when I actually refactor the code and integrate it into my sound library. So So IMF source reader pointer to P reader equal to null. There. I prefer no pointer, but whatever. We'll play things your way today, Microsoft. There. Auto is equal to, okay, so the source file, it's gonna probably be a long string. And I think it was called test.mp3 is what I named the file that I had prepared. Let's open the folder. Let's go, yeah, test.mp3, there we go. It's some music that I found on my computer. And that is what we're gonna be using. So we want to create that dude. And then what we do is we go if P reader, basically if it's not null, then P reader pointer to release. Usually I like to set it to null afterwards as well, but right now. So yeah, you got to release, when you got a pointer to something in COM, you got to release that when you're done with it, because it's got reference counting. That's how it works. So I guess we could try this now. This should load our MP3 file. So we start up good, and then H result S OK. So it did succeed to load that, and that means that P reader is now pointing to MF read, right? Yeah, we're not going to get any information on this thing. We don't have debug data for this. So all we know is it is pointer to some kind of COM interface, but we don't really have any good info on it. But that's fine. That's what we expect. We're working with COM. So now we got the reader all set up. Source reader. Now, what's next? Well, they create a file. We don't need to do that because we're not going to be saving to a file. Then they call write wave file, which isn't, if you look through this whole thing, you realize that's not an API function. That's just another function that they have in this tutorial. So the function does the following: initialize, startup, create source reader, and create a file, then calls the application defined write wave file function. That's this one here. And releases, yeah, okay, so write wave file is where most of the work is going to be done. This one takes the pointer to the reader, the interface, takes the handle to the file, and it takes MSEC audio data, the maximum amount of data to write to the file. For whatever reason, I don't know why they put a maximum, but it doesn't really matter, does it? It's not something that I'm interested in anyways. Configure audio stream. This is also another thing that they're doing. So it's probably a thing that we're going to have to do. It's another function that they've made here. Write wave header. This is probably going to be useless, but when they're writing the header, they might have to load some information out of the MP3 file. And I would also like to load that information, so I'll have to look into this. Calculate max audio data size. Write wave data. This is probably where the magic happens, where the samples get converted out into PCM. This is probably completely useless. Fix up chunk sizes. That's probably stuff for wave format. And there you go. So first things first, configure audio stream. What does that do? The configure audio stream function initializes the source reader. Initializes the source reader. This function receives pointer to the IMF media type interface, which it uses to get a description of the decoded audio format, sample rate, number of channels, and bit depth. Yeah, this is information that we're going to want because we have to compare it to our audio system to see if the file is compatible. Right, so it says initializes the source reader. It's kind of weird because I figure that this here is what would initialize the source reader, right? Create source reader. Creation is different than initialization? I don't know. Configure the source reader. to decode the audio stream in the source file. Also returns information about the format of the decoded audio. Fair enough. So apparently you don't have a separate COM object for the converted stream. It's not like you have the source stream and then the converted stream and you pipe the source into the converted and it does something. I don't know. It's all just one thing. You can configure the source to output samples of the converted type. Maybe. I don't know. We'll see. What do we got here? So, set stream selection. Select the first audio stream and deselect all other streams. So I imagine, depending on the file type, because this code doesn't seem to be specific to MP3, so it could probably work for other kinds of audio or media files, and therefore you've got to select a stream. Set stream selection, MF source reader, all streams false. I don't really understand. Source first audio stream, true. All right. So apparently you deselect all streams and then you select only the first stream. That's what this is doing. All right. Well, sure. Seems good to me, I guess. So let's just put a comment in here. Configuring source stream. Creating source. Configuring source reader? I don't know. And then we're going to paste this in here. And I'll just use the same H result or whatever. It doesn't matter at this point. I'll figure out what I want to do later. Probably in the final version, I'm going to be checking every single return value and throwing an exception if shit goes bad. For most of them anyways. So create a partial media type that specifies uncompressed PCM audio. Alright, so I think did I skip one here? No, so we're selecting the first stream here. Then what are we doing? Create a partial media type. I don't know what partial media type means. That specifies uncompressed PCM audio. So basically we're creating a media type that specifies PCM audio, right? So we create a media type and we set its GUID, major type, to audio. And we set its subtype to PCM. Right. So they're using a kind of, I don't want to say polymorphism, but basically they're using a hell of a lot of enumerations to set what a particular object is instead of using separate classes for every object. If that makes any sense. So uncompressed audio type, P partial type. Apparently we're going to need this, so I'll put that in here. And then we're gonna do this. I'll just copy their comment as well. That wouldn't hurt. So we create the partial type and the other. Well, it works. It's defined. I was kind of expecting this to change color, but whatever. So yeah, I'll just create some stuff. I guess I could try to run through it, even though it's not. I'm not matching the creation and the releasing. It's not going to be an issue. So yeah, we'll step to this. We load the MP3 file. H result still SOK, so that was fine. And this one, fine. So no problem with these function calls. Set up some pointers to hold shit. And yeah, that worked. And that worked. And that worked. So everything works. Great. I wouldn't expect any problems at this point in time. Anyways, what's next? set this type on the source reader. The source reader will load the necessary decoder. Set current media type. That's interesting. That is interesting. So even though we're loading an MP3 file in there, we set media type to a different type, and it just loads a decoder, so that when you read out of the reader, it will use the decoder to decode from the actual type of the file to the type that you have set it to. This is how I am interpreting this code. So get the complete uncompressed format. That's interesting. So you set the type, you set a partial type, and then the object will give you the complete type. I guess because the partial type only specifies things like PCM, right? The complete type will tell us now the bit depth and number of samples per second, right? Because that can change. You can have PCMs of different bit depths, different samples per second, all sorts of things. Interesting. So let's just copy this stuff, get the complete uncompressed format, copy that, and ensure the stream is selected. That seems weird. Seems very weird. Get the complete uncompressed audio type. Right. It seems weird that we have to do that here when we already did it here. And it says like ensure, like it could be unselected. It might be, it might not be. I don't like that. I don't like when an API is like, shit might happen. Let's just do this in case. We're not sure. Let's just do this in case. I fucking hate that shit. But whatever. I don't actually care as long as it fucking works. As long as it loads MP3s. If it loads other files, that's great too. This succeeded thing, by the way, is just a macro that checks to see if the H result is greater than or equal to 0, which I guess means success. Interesting. I thought it was going to check to see if it was equal to SOK, but actually, apparently anything that's 0 or greater signifies success with these H result values. Anyways, moving on. All right, so we do. What do? We get the complete format. Now, once we have the complete format, return the PCM format to the caller. Interesting. So we get the format. Return H. Okay, yeah, because this is passing in, right? This is passing in a pointer to a pointer, and that's going to be filled by this function. And that's why this function is calling addRef, because it's making another pointer own this COM object, so it has to addRef. This is the opposite of release, by the way. And then it releases the pointer that was acquired in here. I mean, this isn't actually necessary. You could have just basically taken the reference that was assigned to this audio type thing and passed it out through this, if that makes any sense. So you didn't need to addRef. If you just get rid of this addRef and then get rid of this safe release, it's the same in the end, but it doesn't matter. This is a very methodical way of doing it. I do not disapprove. That being said, we're not doing that because we're not making a function. So where am I here? Ensure the stream is selected. Return the PCM, and we don't need to do that. So this one here, get the complete uncompressed format, is going to be this one. Put that in here. This one, I like to put my local variables where I'm using them. Other people like to put them at the beginning of the function. That has advantages. It's nice to see all of your locals right at the top. Back in the old days, back in C, you had to declare all your locals at the beginning of the scope. Now you don't have to do that, but it doesn't matter. I don't care. None of this code is going to make it into the final anyways. Just testing shit. Just making sure shit works. So, now what we have is we have this thing, uncompressed audio type. And this will probably allow us to get some information. So, configure audio stream is called, and it fills this pointer. And then we call write wave header using P audio type. Right? Now we're only using it, we're not filling it, so we don't put the address of the pointer, we just pass the pointer in. So write wave header is the next stop on our bullshit deconstruction. Nice short one. I like them short. Create wave format EX from MF media type. Is this, this is an MF function. So there's a function that actually just fucking creates a wave format data structure, or fills a data structure from MF media. Now wait, let me think here. First of all, wave format EX P wave is equal to null. So what that means is we're not creating a structure that this thing fills. We have a pointer, and this thing is going to dynamically allocate memory for it. I guess that makes it flexible, but it also means that now we have to figure out who has to deallocate that memory. It's a situation I don't like, but I see why they might have had to do it. So, where does this get freed? That's what I want to know first of all. Co-task free memory. So we have to call a special COM function to free memory, which is bullshit. This, my friends, is what I like to call bullshit. This is how you don't... I guess I shouldn't shit on it too hard because, I mean, you know, how many APIs have I written from scratch? But still, I don't like it. I don't like it. Gentlemen, I don't like it. So, PCB written is equal to 0. What the fuck is this? Oh, that is the size of the header. So we need a D word that is going to know how much bytes were written, right? No? No, that doesn't, that's something else. That's for how many bytes this thing writes to the file, I imagine. Not important for us, but what we do want is we want this wave format pointer. So let's do that right now. I wonder if there's a smart pointer for COM task memory or whatever you want to call it. Because I know there's a smart pointer for COM interfaces. I might have to look into that because I like me some smart pointers, but not now. Not now. So, first thing we do is we take the P media type P wave, that is, I don't like the name of that, CB format. So it needs int 32 that it's going to fill with the amount of bytes of this thing, I guess? I don't know. I don't know why I want to know this, actually. Write the wave D word header is equal to this. Okay, so that's the header, and then this is the wave format EX. We don't need a header. We're not writing a wave file. We probably don't need CB format either. We don't actually care. Do we? Do we care anywhere in here? Write to file. We don't care about that. Write to file. We might care. We might care. No, write to file is a Windows file writing. This is not another function in here, is it? No, it is a function in here. All right. Write file. Nah, it just calls this one. What? I don't know. It doesn't matter. It's a weird wrapper. All right. So what am I doing here? Well, first of all, we're going to call this function now. Yeah, the name is different. What did we call it up here? P uncompressed audio type. That's what I believe we called it. So let's put that in here. And it seems to like it, so that's good. Next thing I'm going to do, I'm going to ignore this. write to file, ignore that. So we don't want to write the header. What we want to do is we want to inspect what is going to be in that header, because I want to make sure that I'm loading, that I'm getting my information that I need. So we can do that in the debugger. So let's set a breakpoint. Let's just run this fucker. We haven't checked our code in a while. Let's see what's going, and we'll get some SOKs. All is well in the world. So far, so good. What's the next one? Set current media type. That worked. Now let's get the complete uncompressed media type. That apparently worked. P uncompressed audio type, which again we can't. Oh wait, IMF attributes. That's actually something, but it just goes to I unknown, and so we're not going to be able to get any information here in our debugger. No information for us, but we can go into set stream. Yeah, this is the weird thing, just in case thing that I don't like. And here we create wave format ex from media file. Okay, that worked. CB format is 18, so that means that the header is 18 bytes long, or this thing, the wave format ex. Now, if we go to wave format, if we go pwave, just dumb name by the way, we can see this shit. CB size, I don't know what that actually entails. That might be, this doesn't matter. We get 16 bits, we get CD audio sample rate, and we got 2 channels, so it's stereo. This is basically the information that we want, because that's what we're going to compare with our sound system to see if it's compatible with our buffers. So we can get that information by calling this function, which gives us this thing. Then what we want to do is, we call this memory freeing shit here. And that should free the memory if it was allocated. If this is a null pointer, it should do nothing. I haven't looked it up, but I imagine that's how it works. That's how normal free works. So we create the wave format, and it was good. Next thing we want to do, let's go back up to our top level, not the semi-top level function. So set current media type, blah blah. Go up one more. Here, write wave header. So we did that. And if that succeeded, calculate max audio data size. So this will tell us the maximum amount of buffer that we need to hold the data. So this is a useful function, because I imagine, I don't understand, but I imagine like files with like variable bit rates and shit. You can't get an exact how many samples that's going to be unless you run through the entire file. So this will give us at least an upper limit on how much memory we have to allocate so that we can decode the samples into a buffer. And then when it's done, we can check how many samples were actually decoded, resize the buffer, and that is going to be our final buffer that we're going to use for our audio system. So we want to look at this function, which I imagine is, again, another function that was defined in this one. Calculate the maximum data size. Because the file size is stored as a 4-byte value in the file header. Wave files limited to blah. PCM audio has a constant bit rate. So you can calculate the maximum data size from the audio format as follows. Get the audio block size and the number of bytes per second from the audio format. Alright, what is this bullshit? Bytes per second. Get attribute. So the attribute, block alignment, attribute, bytes per second. Audio clip size. Moldiv? What is this bullshit? Is this a function? What is moldiv? Size of the desired audio clip in bytes. Largest possible size of the data chunk. Max D word. Minus CB header. Right. Okay. Audio clip size. Right. This is basically just covering your ass in case you somehow loaded an incredibly long audio file, and it will be longer than what is possible for a wave. I mean, we don't have that problem because we're not actually storing a wave file, but round to the audio block size so that we do not create a partial audio frame. So, I mean, this is probably not important, but the rest of it is going to be useful, I guess. Before I go any further, though, I'm kind of creating shit willy-nilly here and not actually freeing it. So, P uncompressed audio type. Let's go back down here. Let's copy that. So what we want to do is create one of these, two of these, and want to match them. So this guy here is going to match in here and in here. And then the one before him, there you are. You are going to match here and here. Just make sure I'm, keeping my pointers, my interfaces all cleaned up by the end. Not that it's super important here. This is just a test. I could probably ignore all of this, but I like to, just in case. Later on, I'm going to be using smart pointers for my COM interface pointers, so that's going to be the thing. So, basically, you want to copy this shit. And put that in here. So here we say calculating maximum data size. I don't know, doesn't matter. So got some stuff here. P audio type is not the name of our thing, no, is it? It's this one. P uncompressed audio type. It's what it is, and it's also what it is here. So interesting. Get attribute from block alignment and average bytes per second. Fair enough. That's interesting. That's just information about the audio type itself, though. That's not really information about P audio type. What are we passing in here? Let me just make sure that I'm doing it right. That I'm not doing the wrong thing here. So, wave write data. Configure the source reader. Yeah. Where is it? Right wave. Calculate max audio. P audio type, which was gotten from here, which is configure audio stream. P reader. Yeah, okay, so P reader and P audio type different. Yeah, so P audio type, that's just the PCM. That's just the full PCM with the information that was taken by connecting it with the reader. The how many bytes per second, how many channels, etc. So we're just getting information out of that. Now audio clip size is equal to bytes per second, milliseconds audio data. Now this is a problem. And the problem here is that we don't have a desired audio clip size. We want to load the whole fucking thing, right? What is this fucking mol div? Where does this even come from? I've never heard of this function before. Anyways, probably some Windows bullshit. Here's a problem. Yeah, so we need to know how many bytes there's gonna be of this fucking shit, but we don't. This is a problem. This tutorial is not gonna give us this information. It just takes a fixed size, but we want to know the size. That's fucking annoying. I don't know. MFMT audio. So we can use these functions to, but that's getting information out of this audio type. We want to get information out of the reader, right? Where's the reader? Yeah, the P reader, because we need to know how much is there? How much? Tell me how much, but I don't know how to do that. That's going to be a problem. This tutorial is not going to give us everything handed on a silver platter. We're actually going to have to figure some shit out. Kind of annoying, but that's the name of the game. So let me think here. We need some search. We need some search. IMF source reader. Get number of samples. Using source reader to process media data. Enumerate number. Process data from the source. Seeking playback rate. Getting the file duration. MF duration. Is that... He gets in 100 nanosecond units. Divide by 10 million to get the duration in second. This is good. If we know the duration of the file in seconds, we can just multiply that by how many bytes per second of wave data, and that will give us, this is what we're going to do. This is how we're going to do it. So, all right, so we get the presentation attribute from, where is this? From a P reader, right? And that will give us, again, a big ass number of 100 nanosecond units of the duration of the audio file. And, yeah. So property variant is some kind of weird kind of union type deal, I guess. And then you convert that to a 64-bit integer. And prop variant clear. Why? Why do you want to call prop variant clear? Let us just check this out. What are you doing? Free all elements that can be freed. Okay, so prop variant has fucking heap allocated stuff, possibly. So we gotta do whatever. Okay, great. Good. So let's copy this. All right, what am I doing here? Calculating the maximum data size. So uncompressed audio type. I mean, we don't need to do this because we already have this information, right? We have this information from the wave header. That reminds me. No, it doesn't remind me. It doesn't remind me of shit. The wave header is freed right here. So the P wave, that contains a lot of the information we already need. So you know what? Code that I just copy and pasted, you can go fuck yourself. What I'm going to do, what Chili is going to do is... yeah, this stuff can go fuck itself. Okay. So we paste this in here. Prop variant var h result. Again, we don't need the h result here because we already got h results. P reader pointer to this, that, and if succeeded, prop variant to int 64 is undefined. This is a problem. So you know about the prop variant, but you don't know about prop variant to int 64. You know about prop variant clear. Why is this thing not... This is a problem. Did I mention this is a problem? Because I'm fucking... Well, first off, let's go long, long, longly, long, and duration. Fins duration. What is that? Okay, it's a pointer to a long. So, no, stop it. Stop. There. So pass that in by pointer. All right, now this guy, what is your fucking problem? What do you want? Hurry. Property system reference. Prop var util.h. Prop sys.lib. Okay. Windows desktop search. Interesting. It's part of desktop search. Whatever. So if I put this in here, maybe with a little bit of modification. Yeah, there we go. If I put that there, why is there so much red? There we go. Fixed it. Nailed it. Might have to include another library, but we'll cross that bridge when we get to it. So prop variant 2int64. Let's try to build it right now. Yes, unresolved external symbol. How did I know? So prop sys.lib. Welcome to the jungle. Shit, now I gotta fucking copy that again. Yes, and we got fun and games. Build that. Good. So, what we do is, if it succeeded, we fill our long with our dong, and then we clear that thing. Good times. Good. Okay. Let us put a breakpoint there. Clear that breakpoint. Let's run. All right. So get presentation attribute. Go. It has succeeded. Var is equal to bullshit number. Step in. Try to fill our duration. What is our duration? Big number. Okay, that's good. Then we clear our variant. And now, let's take this big number here. Can I copy it? Yes, I can. Fuck. No, wait, that's good. All right, now it told us that, where? It told us that we divide by 10 million. So let me divide this by 1, 2, 3, 1, 2, 3. And that gives us 200.56 seconds. Now if I divide 200.56 divided by 60, gives us 3.34 minutes, which is about 3 minutes and 20 seconds or so. And if I go into here, test on MP3, length 3 minutes and 20 seconds. Nailed it. So this will give us the length of the fucker in seconds, divided seconds times 10 million, in units of 100 nanoseconds. So now we use this. What I can do is I can go size t, number of bytes max. So number of bytes maximum in our thingamajig is gonna be p wave pointer to average bytes per second times times duration divided by $10 million. Right? Am I right? Now, scratch my nose. This will have the problem of, possibly making it a little smaller than it might be otherwise, if you know what I mean. Do I know what I mean? Probably not. I want to make this value so that the number of bytes required is going to be no more than this. So it's okay if this was a little big, but how do I do that? I mean, if I add 10 million to this value, if I go duration plus 10 million, 1, 2, 3, 1, 2, 3. Fuck, that's dangerous. 1, 2, 3. There we go. If I do this, then there will be no problem with the rounding. Or, I mean, I could just fucking, this divided by this plus 1 for rounding up, basically. And wait, yeah, that'll add it. At most, we'll be off by 1 second. We'll have 1 extra second of audio data in our buffer size, but that'll be clear. I hope that we'll be able to count the exact number of samples written, and then we'll be able to resize the buffer to that number. So I don't know. I mean, this number here, it's a long in units of 100 nanoseconds. So probably we'll be able to get the exact size of the buffer just using this alone. And won't be able to resize, but I'll cross that bridge when I come to it. You know what I mean? Actually, this is dividing it by. This is bad. I probably want it to be more accurate than just, accurate to within 1 second of error. The way I could do that is multiply first. Multiply first, then divide. So if I multiply this one times the duration, and then I divide by 10 million. This will be very close to the answer. Let's just do this. You know what? I'm tired of thinking. I don't like to think too much. I try not to do it too often. I'm just going to use this, and then later on I'll see how it works. And if it's working bad, I will fix it. This is often my solution to everything. But anyways, moving on. So we now have the number of bytes maximum that we need. So what I can do is I can create a buffer. So let's go STD. Got to get our STDs. STD, unique pointer. You don't know about unique pointer, do you? Shame. Include memory. Beautiful. Now, unique. How do you catch a unique bunny? Unique up on him. Classic. What do I want here? Car. Unsigned car. Doesn't really matter. Array. Pointer to buffer equal to, fuck, I did it wrong. This is not how you use unique pointer. Auto p buffer equal to standard make unique unsigned car yeah, in bytes max. And there you go. This ought to make us a nice buffer to put our shot in. So far, probably so good. Now we gotta actually jam our samples into our sample spam purse. Our sample purse. Where is it? Where is my spamplers? Calculate, okay, we did that. Write wave data. So here's where the magic is gonna happen. Configure audio, no. Right, no. No. Calculate, no. Yeah, that was useless. Decode the audio, right? Wave data. So here's where the magic is gonna happen. While true. Lots of tests and lots of bullshits. So, read sample. That seems clear enough. Where is the samples going into? IMF media buffer. So wait, so there's a buffer? Wait a minute. Where is this what? Where does the samples go? Sample. Byte. No, that's not it. Where's the sample? P sample. IMF sample. Interesting. So you actually have like an interface for an individual sample. Read sample. Then no sample. Convert to contiguous buffer. Get it. What? Get a pointer to the audio data in the sample. Interesting. Then you lock the buffer. Wow, and you have to release the sample every time. That seems incredibly slow. But we're only going to be decoding this when we load the audio file. So it shouldn't be too bad. It's not like you're going to be loading like, you know, the entire discography of Kenny G. Probably be fine. So, what am I doing here? DW flags, nothing. But you pass it in as a, okay, so this one can modify the flags. Interesting. MF source reader, current media type changed. Not supported by wave format. Interesting. Lots of bullshits here. End of input file. All right. So we're going to be copying some shit here. And we're going to be P audio data buffer unlock. Where does P audio data get locked though? P audio data null. Yeah, we'll take it one step at a time here. This is a lot. There's a lot to swallow here, a lot to digest. You know, what's after this one? Finalize the file header. Okay, so that's the last thing that we need. This is the one. This is the final push. So I don't really like while true, but whatever. It's useful sometimes. Flags. Read sample. P sample. P into this cup. P sample. So, yes. Good. P sample equal to null. Beautiful. So, we get an interface to the sample. If it's failed, we break our shit. I'm not going to break. I'm just going to throw runtime error. Fuck everything at read sample. Whatever. Doesn't matter. All right. So we're going to throw lots of exceptions. Like that. And let's leave that there. Doesn't matter. Doesn't matter. End of input file. Interesting. All right. So here in this loop here, we can probably count exactly the number of bytes that we've written to the buffer, or the number of samples or whatever, which will be useful. I'll do that later though. End of stream. This is not a problem. This is when you have finished. So that will not throw an exception. P sample is equal to null. Throw an exception here, I guess. I don't know if you can just have sometimes in the middle of a stream no sample. Continue. That's weird. I'm going to throw an exception anyways and we'll see. But I might have to give myself a note here. Probably shouldn't throw exception here. Final product. Yeah, because this just might happen sometimes. I don't know. But in this code they're continuing, so. Convert to contiguous buffer. Get a pointer to the audio data in the sample. I don't see why p sample here is. I don't see why. Just put that inside the loop. Now, p buffer. Put that inside the loop here. No. Put that down here. Yeah. Do it. Good. So, if failed. Okay, good. If failed. Fuck everything at convert to contiguous buffer. Then we want to lock the buffer p audio data. Why? What is p audio data now? What is CB buffer? CB buffer is going to contain probably the number of bytes of the thing that we locked. And p audio data is going to be pointer to audio data, which is a byte pointer to a byte pointer. And CB buffer D word. That'll be 0. And if failed, fuck everything at lock. Alright, so make sure not to exceed the specified maximum size. Do I care? I mean, I'm going to care sometime, but I'm not caring right now. So, comment that. Write to file. This is not how we're going to roll. So we now have the bytes. And we don't need this. Then we want to unlock the buffer. And then we want to p audio data is equal to null. Nope. If failed. Yeah, sure, we'll put this in here. Fuck everything at unlock. Good. Yeah, update the total run. running total of audio data. So we definitely need a running total of audio data, don't we? We need that. We need it to be here. So size t in bytes total equal to 0. Put a u on the end just because it makes me feel better. This one, yeah, this is signed, right? Good. Just making sure. All right, so in bytes total, in my song off. No, just fuck off. Safe release. See this, I don't know where this is defined anywhere. Don't know where it is defined though. So what I'm gonna do is this. So we put this guy, we say you go in here and here, you go in here and here, and you can get fucked. I don't know where you're defined, and I don't want to look you up. Safe release. Okay, so this should load the shit out of our data. And if something goes wrong, we should get a exception thrown. And at the end of the day, we're going to know how many bytes were actually written. I like it. I think I like it. Yeah. Yeah. All right. So let's step over this. Step. N bytes max. How many bytes is that? That is too big. No, wait, it's not too big because this is wave data. It's wave data, so it's not too big. Probably, maybe correct, it's 10 times larger than the file. Roughly. And that's about the difference between 128-bit MP3 and CD audio, I believe. I don't know. We'll see. All right, so we create our buffer. Bytes total. Step over. Read sample. It succeeded. Not end of stream. P sample is not equal to null. So convert to contiguous buffer. Worked. So what? How much is in a single sample? It should not be much, right? Like 4 bytes or something. Where is it? What am I looking for? First of all, before you ask yourself where is it, you have to ask what is it. So where am I? Oh, we haven't locked the buffer yet. Okay, good. So it's going to be CB buffer. CB buffer is 0. Wait, what? Oh, we haven't. Okay, never mind. We didn't lock it yet. Holy shit. All right. So apparently, P sample isn't just one sample. It is not a interface to a single sample. When it says read sample, it's not reading one sample. It's like reading a whole fuck ton of samples because we've got a huge buffer here. And that's good because that's more efficient. I was a little disappointed if it was going to be one fucking sample at a time. So let's look up at read sample. Read sample. And that's probably not going to be enough information, is it? What if I... No. What if I put it in here? Search that. IMF source reader read sample. That is the one that I was looking for. All right. Synchronous mode. Interesting. It can work asynchronously. Cannot be null. Method block. Doesn't say anything about how many samples are. And remarks, not a lot of info there. PP sample, IMF sample interface receives a non-null pointer, blah, blah, blah. Okay, what is IMF sample in all about? Represents a media sample, which is a container object for media data. One video frame for audio data. Sample typically contains multiple audio samples rather than a single sample of audio. Yeah. So why did you fucking name it IMF sample, though? You could have named it samples, and that would have made it a lot more intuitive. Fucker. Anyways, I'm glad that it's doing more than one sample at a time, is all I'm going to say here. So if we run... Fuck off. If we run to here... Run. We get n bytes total exactly equal to n bytes max. So, it looks like our calculation is actually working pretty well for shit. But the duration of the song might have been exactly 3.20 seconds, so I'm thinking now, what if we have a song that is, the duration is a fraction of a second? Then they might not match up. What I want to do is I want to think here. Multiply this by the duration, divide by this number to give the number of seconds. Number of bytes. The number of bytes, not the number of seconds, the number of bytes. So, this should always be the number that we need. Like, this should just give us the exact answer every time. Because the answer is in bytes. You can't have a fraction of a byte, right? Doing the multiplication first, then the division, should make it all good. I don't know, maybe I'm missing something, but I think that I don't have to resize it after I'm done. So we've got the audio data, we've got it loaded apparently. Now all we need to do is see if I can actually play this bullshit. So what I'm going to do is, for testing purposes, I'm going to go into sound. I'm going to add a constructor. Wrong file, asshole. Where is it? Okay. What constructors do I have? Okay, so I'm going to add a constructor for testing purposes only. Sound byte. I kind of want to make it auto, but I'm going to make it std unique upon him pointer byte array block, whatever you want to call it, reference to a unique pointer. Bitya. There. All right. Make a constant reference. Data. Okay. So what we want to do, like, we just want to copy this like directly into here, though, don't we? That's really what we want to do. Active channel pointers, n bytes. All right. So we need a number of bytes. So, UINT 32 in bytes, and unique pointer, our value reference. All right, here's what we're going to do. So we're going to put in bytes. In bytes. We're going to go... should be like P samples or something. Something a little more good. So P data. std move. P samples. So many P samples. Alright. Null sample. Null second. What is this? That's fine. That's a static constant. Doesn't matter. Looping is equal to false. Loop start, loop end doesn't matter. Should be good. This should just do it. So now we're going to go into game.cpp. I believe we need to include sound.h. Let us do that. And let's go back down here and find our shit. So now what we want to do is we want to go sound, jazz, jizz, and number of bytes total, and std move p. Fuck, what did I call it? I forgot what I call it. Wait. I'm not copying the data, am I? Am I not copying the data yet, though? I should probably copy the data, is what I'm guessing. But anyways, I called the thing... P buffer. Fair enough. I'll accept it. Buffer. So we create a sound jizz, and then we go shit. Then we go shit. Can't create the sound here though, can we? Fuck. Because the sound, it's gotta live on sound jizz. Alright, well, now I've made a big fucking cock up of it. So, sound jizz. Why are you pissed off? Yeah, you're fine. Okay, we go into game. No, we go into game.cpp. Scroll all the way up. Copy this. Cut that. Put that in here. So now you know about sound, right? Create an empty sound. Then in here... Fuck, I lost... Shit. Alright. Where's the loop? Here's the Guadalupe. We go jizz is equal to sound n bytes total std move p buffer. Bam. Good. That works, right? I believe I have defined all the proper move and all the assignment and all the good stuff. So this should work. Now we just gotta fucking copy into the buffer. Into the buffer though. How do I want to copy? Unlock the buffer. No. Lock the buffer. And then what do? Then we go P audio data. No. CB P audio data. Yes. Okay. Hello, my name is Chili. I program. Sometimes. Copy. First. So in iterator. In is going to be P audio data. Out. No, last one is going to be P audio data plus TB buffer. That's the number of bytes. Output is going to be P buffer at n bytes total address of. That works, right? Maybe that works. So we copy shit into our shit, and we're not checking to see if we ever go outside the size of the maximum, because we don't care. We don't give a fuck. But this should load samples into our P buffer, and then we can move them into a sound, and then we can, if window.keyboard shut up .key is pressed. This is a terrible idea. Constant auto, no. If window.keyboard .key is empty. I can't get those fucking... I hate the fucking Japanese keyboard. It fucking shifts over the parentheses by one key. And that fucks me over, because I can never remember which keyboard I'm typing on. Okay, so if key is not empty, const auto event E is equal to windows.keyboard.read key. If E dot is press and E dot get code is equal to VK underscore space, then what we're going to do is we are going to go jizz.play. So whenever we press the space bar key, we're going to play the jizz once. Play that jizz, maestro, and everything should be fine. Not going to run into any problems. Of course not. We didn't even build it properly. Okay. No, I don't think we will run. Argument conversion from size T, possible loss. Really? Is there really a possible loss of size from loss of data? Oh, okay, I guess there is possibly a... Well, you know what? Do you think I fucking give a shit? Where's the other errors? What's the real problem here? Copy. Unchecked iterators deprecate. Call to copy with parameters. That's right. Doesn't let you copy shit. Alright, you know what? Copy, you can get fucked. Because I'm tired of your bullshit. What I'm going to do is I'm going to go mem copy. And that'll work. Build. A lot better, but not perfect. Where's the problem? Void pointer, constant void pointer, size T. Okay. So this one, yeah, obviously different. This is going to be void, so this is going to be destination. That's this. It's going to be source. That's this. And this is going to be number of bytes. That's this. Okay. Now. Well, it built. Run. Exception. P buffer was null pointer. Exception thrown. Read access violation. Okay, I'm a retard. Break. Probably shouldn't name your data buffer the same as the fucking buffer that you're using for locking. What is buffer anyways? Peace. sample, convert to contiguous buffer. What is buffer? P sample, iMedia buffer. Then we lock it to get this. Right, okay, so let's not name our other thing pbuffer. Let's name our other thing, where is it? Where is it? There it is. P samples. P samples. Okay, now we're gonna load into our P samples like this. Still works. Good. Then we're gonna go down here and we're gonna move that P samples. Build that. Let's see how that works. Good. Run. Okay. So far, so good. Let's press the spacebar. Wait, let's check the fucking audio levels. Okay, let's press the spacebar. Fucking works. It's fucking playing jazz, man. I'm playing my jizz. Sweet. Alright, so this is a success. Now all I gotta do is fucking just rework this code so that it goes into the fucking framework. And maybe I'll do that. I mean, I'm kind of done for today. I'm finished. Let me check my phone. Yeah, I think I'll leave the video right here. What I'm going to do is I'll put this video up and you guys let me know, if this video has a lot of people like it, then maybe I'll show the next part of this where I actually create the class code. I modify the sound to incorporate this stuff into it. If you're interested in seeing that, or if you don't care, then I'll just do it off camera because that's a lot easier for me. But so yeah, leave comment, like, or whatever, and I will see you again with some more of this stuff if it proves to be something you guys are interested in. Either way, see you around.